Good, good day, everyone. We are from the group who are assigned to report regarding Reynolds number. So Reynolds number was developed by Osborne Reynolds, a British scientist and mathematician. He first distinguished the difference between the classification of flow by using a simple apparatus shown. There, this the apparatus again. He used to experiment did nagkalahi nga velocity sa fluid aron maka-identify siya kung kana siya is laminar ba, turbulent or transitional nga flow. Next, from range 1, he classify this flow as laminar kung ang Reynolds number is 0 to some critical value at which transition flow begins. Sa range 2, he called it transition flow. These flows in this range may fluctuate between laminar and turbulent flow. The fluid flow is on the verge of becoming turbulent. So in iya classification is in between laminar and turbulent, and padong na ni siya pa turbulent. In range 3, we called it turbulent flow. The fluid flow there has become unstable. In turbulent flow, there is increased mixing that results in viscous losses, which are generally much higher than in those in laminar flow. Okay, so next, the history of Reynolds number. So, Osborne Reynolds famously studied the conditions in which the flow of fluid in pipes transitioned from laminar flow to turbulent flow. In his 1883 paper, Reynolds described the transition from laminar to turbulent flow in a classic experiment in which he examined the behavior of water flow under different flow velocities using a small stream of dyed water introduced into the center of clear water flow in a larger pipe. So, nag-experiment si Osborne Reynolds atong 1883 using a glass pipe nga naay nagkalinlain nga kapaspason sa fluid niya ang using dyed water aron ma-observe niya aron masabtan niya ang flow sa fluid kung kana ba siya is laminar, turbulent or transition. So again, the larger pipe is glass, so the behavior of the layer of the dyed stream could be observed. And at the end of this pipe, there was a flow control valve used to vary the water velocity inside the tube. When the velocity was low, the dyed layer remained distinct through the entire length of the large tube. When the velocity was increased, the layer broke up at a given point and diffused throughout the fluid's cross section. The point at which this happened was the transition point from laminar to turbulent flow. So this was the formula of Reynolds number nga gina-introduce ni Osborne Reynolds. So the Reynolds number is the ratio of internal inertial forces to viscous forces within a fluid which is subjected to relative internal movement due to different fluid velocities. So Reynolds number ing ana is symbol Re is equals to inertial forces over viscous forces, or is equal to the mean velocity sa pipe times siya sa diameter sa pipe ug ang specific mass or density sa fluid over the dynamic viscosity kung ang given is naay density ug naay dynamic viscosity. But then, kung kinematic viscosity is given other than the mean velocity of the diameter sa pipe, so mao ni ang gamitang formula. Reynolds number is equals to mean velocity times the diameter of the pipe over the kinematic viscosity. So, kani di ay nga formula kung kani ang gamito ang results ani maka-identify ta kung ang maka-identify ta sa flow sa fluid kung kana siya is laminar, transitional or turbulent. So and the next slide, we can identify sa kanang result, sa within the result is laminar, turbulent, or transitional. Here, the upper limit of laminar flow to be defined by kung ang Reynolds number is 2,100, greater than 2,100 but less than 4,000. The lower limit of turbulent flow, defined by the lower critical Reynolds number, is greater in engineering importance. It defines the condition below which all turbulence entering the flow from any source will eventually be damped out by viscosity. The lower critical Reynolds number sets a limit below which laminar flow will always occur, having a value approximately 2,100. The region of uncertainty exists is between 2,100 and 4,000. So, or the cold transitional region. So, mao dito ang laminar flow. Kung ang result sa formula beta sa Reynolds number is less than 2,000, then consider siya as laminar flow. Kung ang result is greater than 4,000, then it is a turbulent flow. So, mao ni ang concept of a critical Reynolds number. Next, mag-example ta. Aron ma-internalize na to. Unsay gamit sa formula sa Reynolds number. So, water of kinematic viscosity 1.15 by 10 to the negative 6 square meters per second flows in a cylindrical pipe with 30 mm diameter. Calculate the largest discharge for which laminar flow can be expected. What is the equivalent discharge for air? Kung ang velocity sa air, na viscosity sa air is 1.37 by 10 to the negative 5 square meters per second. Taking Reynolds number is equal to 2,100 as the upper limit for laminar flow. So, muna ang formula atong butang. So, 2,100 is equal to velocity. 2,100 is equal to velocity. Atong pangita ng velocity aron makuha nato ang discharge. Kaya discharge is equals to velocity times area man. So, mo to velocity times sa diameter. Ang diameter is 30 mm man. So, in meters, 0.03 over 1.15 by 10 to the negative 6. So, velocity is equal to 0.0805 meters per second. Ang pagkuha sa discharge niya is velocity times area. Ang velocity is 0.0805 times sa area, pi over 4 times 0.03 squared. So, discharge is equal to 5.69 times by 10 to negative 5 square meters per second. Muna sa tubig. So, arita sa air as 2,100 is Reynolds number niya. 2,100 is equal to velocity sa air atong pangitaon sad times 0.03 diameter over 1.37 by 10 to negative 5 ang iya viscosity. So, makuha na to ang velocity sa air is equals to 0.959 meters per second. So, ang discharge, makuha na to velocity times area, 0.959 times pi over 4, 0.03 squared times 0.03 squared. So, the discharge is equals to 6.78 by 10 to the negative 4 square meters per second. Nga naon ang pagkuha, ang paggamit sa formula sa Reynolds number. Next is we will define laminar and turbulent flow. So, laminar flow, the fluid particles are constrained to motion and parallel paths by the action of viscosity. So, mauna siya ang resulta sa laminar flow. Ang iyang motion is straight and parallel. Tugod na sa ang viscosity kay high man, and then ang velocity sa fluid is hinay. So, in results, ang ana iya motion, and then ang iya profile is parabolic. And then, laminar flow, it's the shear and stress between adjacent moving layers is determined in laminar flow by the Newton's viscosity law. So again, the laminar flow has low velocity and or high viscosity and is stable against such disturbances. So, nga dito sa turbulent flow. Turbulence is characterized by the irregular chaotic motion of fluid particles. Mo na iya motion sa turbulent flow. Tungod na sa low ang viscosity ug high ang velocity. Paspas ang flow sa fluid. Mo na yung ana ang iya motion. At any fixed point in a complete developed flow, the instantaneous velocity and consequently the instantaneous pressure fluctuate regularly about a mean value with respect to both time and spatial direction, increase in flow velocity and or decrease in fluid viscosity. So, maot na gito. Ang iya particle sa fluid is nagka-budyat ag dili parallel unlike sa laminar flow. So, that's all for summarized discussion pertaining Reynolds number. Pero mag-present sad ko og video regarding ani nga topic aron ma-internalize og ayo.
Hello my dear students, welcome to this online video lecture on fluid mechanics. So today in this video, we're going to have a discussion on Reynolds experiment. So before going to this experiment, let us know the definition of Reynolds number. So Reynolds number is a non-dimensional parameter which helps us to identify the type of flow. So generally the Reynolds number is given by inertia force to viscous force. So based on the Reynolds number, so the fluid flow is characterized into laminar flow, turbulent flow and transitional flow. So to understand these flow, the Reynolds experiment was conducted by O. Reynolds in 1983. So this experiment gives a clear picture about how laminar and turbulent and transitional flow takes place in the fluid flow. The experimental setup consists of water tank, a dye tank and a glass tube and regulating valve. In this experiment, the water from the water tank is allowed to flow through the glass tube. The flow velocity is varied by operating a regulating valve. At the same time, the liquid dye having the same specific weight as that of water is introduced into the glass tube, and during this operation the following results are observed. At a lower velocity of in a flow, the filament in the glass tube is in the form of in a straight line. So this straight line of filament dye is parallel to the glass tube, which indicates that flow is laminar. When the velocity of a flow is increased to some higher values, the filament dye is nowhere a straight line and it takes some wavy nature, which indicates that the flow is not laminar. When the flow velocity of a fluid is increased to a higher value, the complete wave of a dye disappears and it diffused into the water. It means that the fluid particles of a dye are moving in a random fashion, which shows the case of turbulent flow. In this case, the mixing of dye filament and water is intense and flow is irregular, random and disordered. So in a general case, if the Reynolds number is less than 2000, then the flow is known as laminar flow. If the Reynolds number is more than 4000, then the flow is called turbulent flow. If the Reynolds number lies between 2000 and 4000, then the flow is transitional flow.